Hi, everyone. You ready? Okay. I'm John Abd-El-Malek. I'm excited to be here talking about the end of content, or more accurately, what the future of content is. Today I'm going to talk about the motivations, why, what's driving these big changes we're making. I'm going to talk about the goals and opportunities that we think this provides. I'm going to talk about exactly how we're doing this and what the end state looks like. And I'm going to give a few examples of how this simplifies feature development. So to start, Blink, originally could be considered as a rendering engine. This is, before it added all these powerful capabilities. It was a leaf node because it was shared with other projects that didn't have multiprocess, that didn't do IPCs. So all the brokering to the browser process was done through content. But as the web got more powerful, and Blink is not just rendering pages, but running web apps, there were a lot of features that spanned multiple processes. This kind of, as we added more and more of these features, this ended up causing a lot of extra overhead, duplication, performance issues, and security issues. So kind of a lot of what we're trying to do now is figuring out how we can improve this. Sorry. So I'm going to go through a few examples of why we're doing this in detail. So this is how typically a feature that spans processes was implemented. As you can see, there are a few issues here. The first one is there's a lot of duplicate structs. So between Blink inside core and Blink, the public API and content, sometimes it has 3 structs for the same thing. This obviously led to a lot of unnecessary conversions, which could be a source of bugs, but also just performance overhead. And then there's a lot of plumbing, right, through different APIs to get through the various layers. And there's also a lot of IPCs. And lastly, feature owners had to work across many directories. And these directories had different styles and conventions and different types, like WTF and STL. Another kind of issue that we've been running into is a lot of duplication. Since each framework was a leaf node, each had its own embedded APIs to get access to things like networking. And so, for example, there were different ways to make network requests depending on whether you're an extension, whether you're in render, or a plugin, or in the browser process. And similarly, for things in the browser like bookmarks, it was accessed differently, whether it was web UI, or other C++ code, or Java code in the browser, or extensions. So this is just 2 examples, but there are many more. And kind of together, it added up to a lot of just extra work that people had to do as they modify and write new features. Another issue is performance. The current architecture kind of depended on routing everything through the browser process. It wasn't really possible to abstract where something lives, kind of like the caller and the callee of an IPC kind of had this inherent dependency on which process the other person lived in, or the other code lived in, and whether was sandboxed or not. As an example here in networking, let's say there was a document and a service worker running in the same process. Since all networking was routed through the browser process, there were 4 process hops for this code that's running in the same process to talk to each other. This obviously caused kind of a lot of latency. Another issue with performance is just the IPC. When the page is running kind of far from the storage code, and let's say the feature uses a lot of data, it can cause denial of service for the IPC channel. It can also kind of cause out of memory in the browser. And this isn't even malicious code, right? And then lastly is security. There was a lot of code running in the browser process. Things like UI, networking, and storage. And they didn't really need to run on Sandbox, but they ran there because it was like the one process that everyone can talk to. So how do we make this better? It comes down to the 4 principles. We want to make things faster, right? Better speed. We want things more secure. If something doesn't need to run on Sandbox, it doesn't have to. We want to improve stability by running less things in the browser, so when they crash, we can restart them. And we want to make things simpler. Keep web platform feature code together, We want to reduce the boundaries and the duplicate ways of getting at the same data. And how are we doing this? There are a bunch of different projects going on that are eventually going to slim down content. The first one is modification. So this is a new IPC system that replaces the old one. And this allows IPC to be called from Blink. Why didn't we use the old one? And the reason is the old one was based on macros, and it didn't have the ability to kind of generate bindings for different languages. So you couldn't call it from Java or JavaScript. It also kind of generated one type of C++ code. So you couldn't call it from Blink without converting from WTF to string, and this would just be unnecessary. So with Mojo now, you can generate bindings for like, in Blink, it can call it using its WTF types without any extra conversions. And in the browser, it can read them off using STL types. The other project is Onion Soup, which is once things are converted to use Mojo, this is just a subset of Onion Soup. Of course, there's many other things in Onion Soup, and Kantara has already talked about that yesterday. But the kind of neat thing here is we can move the code in content render to Blink. We can also move code in content child. That's a lot of it is historical reasons when we used to run workers in a different process, but that could also move to Blink. And lastly, there's servicification, which is, I'm going to spend a few slides talking about that, but the summary is we can move large subsystems like UI or networking and storage from content browser to services. We can also move web platform implementations in content browser to Blink. So what is servicification? It's a project to move Chrome towards a microservice architecture. Services are well-defined, so they have a clear API. Instead of having many different ways to access things depending on which process you're in, it's the same. It's reusable, so we have fewer ways of doing the same thing. It's decoupled from other code, so it's possible to run services as a subset, so you can start the browser and only run networking, for example, instead of bringing up everything. The system is layered. So for example, LevelDB is built on top of file system service, and then you can build like local storage on top of LevelDB. Services are also exposed to Blink with appropriate brokering in the browser process. So Blink now doesn't have to kind of create its own interface for everything. Here are some of the projects that we've completed already and we're working on and are going to work on. So there's a bunch on the left. There's ones like related to storage and device access, and progress working on networking and download, which will enable to move networking to a sandboxed process. There's UI and Viz, which was just talked about, and Chrome OS, Ash, and then there's like process launching and permissions, identity, and so on. These things are also all from content browser. So as we move them out to a service, content's going to get slimmed. And some things we're planning on, things like navigation service, which will allow us to have different frameworks in the render, and notifications and sync. So this is what the end state looks like in terms of the code layering. As you can see, Blink moves from being the bottom, right, to being in the middle. And this is nice because I can access all these foundation services for things like process launching or file system, device access, and networking and UI. And one thing I just want to point out in here is even though you can see in the boxes and the frameworks, we have Blink, PDF, and Blimp. We think this is a better way to kind of structure the code so it can support generic frameworks without kind of adding hooks everywhere. But all the foundation services are all heavily optimized towards Blink. So kind of Blink is the most important framework that all these foundation services are optimized for. It's also the second most important framework and the third most important framework. Another way to view this is the process model. Eventually, if you have a device with a lot of RAM, you can run a lot of different services in their own process for stability and security. And they can just talk through Mojo, and if they crash, we bring them up again. However, Mojo and servicification makes it very easy to move code to different processes depending on the device capabilities. So let's say you're on a constrained device with really like an if statement. You can move something to run in a different process. So you change things. To kind of give an example of how this architecture simplifies development, especially of Blink features, I'm going to use local storage as an example. So this is how things used to be implemented. There was a code running in the browser and in the render across 2 different directories. With Onion Soup, this becomes much better because you can remove the code in content render, and the code in Blink can talk directly to the browser. Specification allows us to kind of simplify this further, and we've already shipped this new implementation. What it does is allows the render process, specifically Blink, to talk to a LevelDB service that's running in a different process. That way, you've removed the local storage specific code in the browser, and the only thing there is a LevelDB service that's generic and can be used by multiple features. Right now, it's running in the browser process, but there's nothing stopping this from eventually sandboxing this. IndexTV kind of looks similar. Right now, it's spread across 3 directories. And again, Onion Soup will simplify this to 2. But the neat difference here is that unlike local storage, which shares one database for all origins, there's one database per origin for IndexTV. This allows us to give the render access to the database so we can move LevelDB service to run completely in the render. Then we avoid kind of issues with out of memory and kind of denial of service for the IPC channel. So at the end, do we think content will go away? I mean, if it does, that's great. We're not really sure yet right now what will remain once we're done. There's a lot of projects, right, spanning many different offices. We're confident that all of these will make the code base better and simpler and kind of make it more productive for engineers. And we're kind of, when we're done for a lot of this, we're going to look at what's remaining and figure out, okay, like what's the next step? Is this small enough to leave as is, or can we, simplify it further? So with that, I'll open it up to Q&A. Yes, in the back. The question is like the different apps. I can go back to the diagram. So the question is, can the different apps share resources? What kind of resources do you mean? Oh, no, that is not planned. I mean, there's security issues. Imagine if someone installs another app in the system. We wouldn't want it to modify, for example, cookies used in Chrome. Other questions? Kitaro?
So in end stage, do you think Blink should be one service, or are you ready to
I mean, we look at Blink as a framework. Like service is unfortunately kind of a very overloaded term right now. So what we wish we would rename source service to like source foundation service. And then like Blink is built on top of services. But like we view Blink as a framework. A lot of the things, I mean, right now, for example, IndexTV, if in the future we find that IndexTV is used by other frameworks or other applications, and we want to run it without Blink, maybe at that point, then you remove IndexTV to a service, right? But if it's only used by Blink, then there's no need to take it out. Okay, another question. Yes? The render already has file access. I mean, you can imagine things like file system API already give it access. There's a bunch of other cases. But as long as we know that the render has access to that origin, just running LevelDB in that, it would only be LevelDB for that origin. So it wouldn't be able to access LevelDB for other IndexDB origins, or even LevelDB service for other features like local storage. So on. Oh, yeah, we already do file access in the render, but it's kind of tightly scoped. We can control specifically which files or directories the render has access to, and it can't, traverse or escape out of these directories. Other questions? Anything else? Going once? Twice? Okay. Well, thank you, everyone. And I'll be around